esteemed academic professionals, and the ladies and gentlemen. It is my honor to warmly welcome you all to the 33rd installment of the prestigious Inaugural Lecture Series organized by the Faculty of Graduate Studies, University of Montreal. To commence today's session, I cordially invite Professor Rohinton Emmanuel to introduce the professor for the day.
Hello, I'm delighted to welcome you to the professorial lecture by my very good friend and former colleague, Professor Narein Perera. I've known Narein for a number of years, over 27 years now to be exact. Initially as a year master to his third year of BSc in Built Environment in 1998. And I continue to be involved in his academic development, academic journey. Most specifically as an external advisor to his PhD work. Narein, as a number of you would know, is a renowned architect. He has won numerous awards both within Sri Lanka and outside, from the Sri Lanka Institute of Architects, as well as from India and Malaysia and further afield too. But that's not my purpose today, to introduce Narein from an architectural perspective. I want to take a little bit of time to introduce his research interests, specifically in the urban climate field. We worked a lot on this concept of local climate zone, which already existed at that time, but Narein sort of developed how this could be applied for climate sensitive planning specifically in tropical climates, which we were fortunate enough to be able to publish as a journal paper in Urban Climate in 2018, which was very well received, I should say. Also, then that work continued into book chapters as well as a more specific mitigation approaches, street trees, air pollution, uh, improvement, etc. And we worked on a number of papers, conference proceedings as well. We were also able to work together in externally funded research. Specifically, I should mention the COSMA project, Climate Service for Resilience to Overheating Risk in Colombo. And that was a UK NERC funded project with University of Moratuer and ourselves and University of Reading. And that really was a wonderful opportunity to implement in practice what we have been working together. Uh, it's also the case that we were able to do some knowledge exchange in this area. We worked with external partners in improving the energy efficiency building code that Sri Lanka has now put in place. So this sustainability guidance as well as sustainable energy guidance was something other stuff that we were able to do. In this, that Narein was able to demonstrate his interest and commitment to urban climate. He has been a visiting lecturer in our Erasmus Mundus joint master program on urban climate and sustainability. He has supported it in numerous ways, and that too is a testament to his commitment to urban climate. I'm sure this gives a very short précis of what his interests are, and you're going to hear more about his research work as well as how that has translated into practice, design practice as well. So I'm delighted that Professor Narein Perera is now a professor and he's making this an inaugural lecture to introduce his academic journey and how he got where he is. And I'm delighted that this has worked out very well and congratulate Narein for his achievement. And I'm welcoming you all to listen to Narein's own thoughts on urban climate mitigation and adaptation. And I wish him well for his continued development in this academic and research journey. Thank you very much.
Good afternoon to everybody. First and foremost, I'm thankful for my presence here and thankful to the man above through whom everything is possible. And also I take this opportunity to acknowledge people who have taken this journey with me right throughout my years in academics and in practice. Very specific people, my family, uh, my parents, my siblings, and my own family, and also my teachers. Prominent among them, as you just met, Prof. Manuel, who has been my supervisor and mentor for a long time. My supervisors and teachers, professors who have led me on this path. Also, this is a lifelong learning process. So each and every person that I have met along the way has emboldened me to go forth and also enrich my journey. Today, I'm given the opportunity to profess this. Very reluctantly, I must say, in this context, but I take this step and take pleasure in imparting or sharing what I have learned through. Today's talk, I will, it's titled Towards a Context-Specific Response. So in this process, as mentioned, my area of interest goes to climate-sensitive design, especially in our context of tropical Sri Lanka. To talk about that, I will speak on two topics or two areas, two general areas. Firstly, on urban scale context, and with it, I would show you some of my research and also the outcome of the research, local climate zone based urban planning for Colombo. In the second part, on building scale context, of which I also teach. In that building scale, with those approaches, I will use my own work, share some thoughts and application, which is very important in our line of profession, where as architects, the application of what we learn is important. Climatic context. We know that we are in the tropics, and Sri Lanka, very especially, is in a unique situation where being almost on the equator, and there are situations where the tropical climate that we experience is varied throughout our context of our country. This is both a challenge as well as an advantage. We know that designing in the tropics or living in the tropics, and therefore design for habitability, has many challenges, some of which are alluded to here. High humidity makes evaporative heat loss very difficult. It's a principal means of thermoregulation at higher temperatures, which allows us to be comfortable in this context. Weak macro level winds. We know that although most of design is based on natural ventilation in this area, at certain parts of the year, we are devoid of it. We know that the wind directions change, and also when the sun is directly overhead, we see periods of no wind, so makes it design difficult. Other thing is absence of annual variations. We almost don't feel any seasons as such. Maybe rain and more rain, but having these aspects are challenges. Further, local and global challenges, especially in this context. Now we see increasing things getting increasingly problematic, where extreme events are not readily known before they happen. Therefore, these consequences can be tragic. One of these aspects that we can pinpoint on is the urban heat island effect. And this is where my studies as well as teaching focus on. Urban heat island as a way to mitigate and adapt. When we talk about achieving conducive environments for living in the urban outdoors, we look at trying to break from the vicious cycle where energy use puts back or exacerbates the system totally. So in decoupling conventional resource use and therefore waste, we can mitigate and adapt. In this sense, we have to look at in all contexts, that is from the urban scale right to the building scale. But on the urban scale or context where people would build has more importance in this area that I have taken on. Therefore, settlement planning is part of the major element that we focus on. The tenets of sustainability into planning is also a critical area that is forgotten most of the time. But here we focus and say that urban planning should be in the design domain. And the approaches to UHI mitigation is a major part of that. Urban context. As mentioned, there are several scales that we dwell upon in terms of design. When we talk about climate sensitive design, it can take on from the mesoscale right down to the micro scale. In my studies, in studies and in applications that we take on, it is the micro scale that we are interested in. That is the scale that a practitioner, urban designer, architect can focus upon. Therefore, a three-dimensional space of the micro scale also allows us to design for natural light and ventilation, which is very much a part of our planning and building regulations. In this purview, the local climate zone as a system that includes climate critical urban parameters. That is, not only do we talk about morphology or physical factors, but the idea that climate also should be built into it is an approach that could allow better application. It is this area that I will stress upon. So the local climate zone classification is a development that has really taken on in this since we have started these studies almost a decade ago. Urban heat island investigators saw several problems to the term urban heat island, where a simple definition of the urban areas being warmer or cooled slower than the rural areas was deemed to be too simplistic. Here, the idea that it should, or the protocol should be more specific so that we can draw upon this. Here, this diagram shows you where these urban climate zones were broken up. In the old system, we would see these, or the building series as urban, and the natural cover series as rural. And the difference between them as UHI or urban heat island intensity. But here, this system shows you that it is much more than that, or can be more than that. So beyond this, it's intended use as a classification tool. It also allows us to fill a crucial void where it is a accepted protocol that people from different cultures and places can come together in a common platform. So when we go into local climate zones, it means the areas that we occupy. And we know in general areas, even though we are moving through a city, certain parts of a city feel different. You feel the difference in your local warming. But in definition, it was urban. So this is where the local climate zone comes in. Local as in a region of uniform surface air temperature, which is 100 square meters to a square kilometer, a local zone, so that it can be taken on later, which we will discuss. Climate, so it's within a certain zone, we would experience a certain climate. The climate is a characteristic parameter that we would feel over a certain amount of time. And then zones. So in zoning these areas and recognizing that each zone is different, we go away from the urban to rural difference and talk about the urban heat island intensity between certain zones. So this diagram on the right shows you these patterns that were developed. So we know that when we are moving through a high density, high compact, high rise area to a more open, low rise zone, we feel different. So this is exactly where we pitch our application protocol. To do this, we recognize that each zone will have its own inherent properties, zone properties. These properties will have physical, it will have metabolic, as well as functions, materialistic functions that define this. We know all of these drive urban heat island. These two sheets, what we call data sheets. The one on the right is the definition, while on the left, it is an example of it. So these factors are self-explanatory, where we see what drives urban heat island. And knowing these factors or these parameters, we can adapt to these, or we can apply these or change them so that we can mitigate. Factors like sky view factor, how much sky we see. We know that the more sky we see during the day allows more solar radiation into the system and warms us. But in the night, more sky view also allows radiation loss. So this is one example of a key factor that drives urban heat island, where incoming solar radiation during the day is trapped within our built forms and structures and cities, and doesn't cool as fast as a rural area. This is one parameter as such. Others that drive are defined here, but I won't go into them in detail. In terms of physical, then also in terms of surfaces. We know that our city surfaces are doesn't absorb water or doesn't allow water to go be percolated into the soil. Therefore, less moisture in the system, less evaporation. With that, less cloud cover in the cities. Cloud cover is pushed beyond the cities, and precipitation is impacted in that way. Another example or another parameter that we look at is what we generate, anthropogenic heat flux, where our activities air conditioning, vehicles, and our own occupation in a dense area would drive the heat or the cooling capacity of an urban area, as opposed to the areas that we won't have these factors. The rural area or area that is open to sky, and the radiation balance can happen more easily. City context. So to look at this, these factors, we took on Sri Lanka and Colombo as a focal point. This is the most dense area in our country, Sri Lanka, and these images show you how this aspect, the whole, not only the whole world, but Sri Lanka itself is warming. The first series of maps of Sri Lanka show you thermal comfort during the hottest months, and the bottom line shows the trend during the coldest months. And in all of these diagrams, we see Colombo on the western coast as a typical area of warming and typical area that is affected by urban heat island, therefore needs that. So to do this, we look at classifying Colombo into local climate zones and then see how we can use these climate zones going forward. So we take the classification in 3 parts or 3 steps that were defined by its authors, Stewart and Oak, in 2011, and then this study was done at the same time, parallel to that. So these are factors that we were able to exchange with them as well. Stewart and Oak are geographers, so therefore their idea of a local climate zone definition was to study or to define, record local level warming. So the establishment of measurement sites and what we call metadata reporting. So the parameters we saw earlier are those metadata that we would report. We would imagine if the context changed, then the warming properties also change. So this was the rationale. For example, in Sri Lanka, our Colombo meteorological station is, we know well, at Baudda Lokamawata, where it has been there for more than 100 years. But very recently, not recently, a couple of decades ago, part of its context completely changed. Example is the British High Commission coming in. So you would imagine where those measurement instruments sat for 100 years without much impact on it. But when urbanization or elements were applied around it, those measurements obviously cannot be compared. So to do that, here we took a different approach to it, where as urban designers, architects, we look at how we can apply to design and so forth. Here, because of that, we looked at local climate zone as urban blocks. In our planning and building regulations also, we take on certain zones, activity zones, etc. And these zones are the places that these regulations are applied into. So here we looked at that in that sense. Urban blocks of characteristic properties that can be defined as local climate zones. Interestingly, after we presented this in similar in forums, Stewart and Oak also changed their approach or modified their approach, where they would go into this urban blocks as the primary way of defining an area of influence. The next step is to collect metadata. So metadata talks about those properties: sky view factor, height of roughness elements, and then surface cover factors, um, and also material aspects of it, like thermal emitters, which will define a local climate zone. Here we see some examples from Colombo. We also see areas that we can define as one local climate zone, but also we see areas that are of mixed use. Now, the local climate zone doesn't look at the context from site to site, but a general area, so that it is of characteristic properties rather than individual, where we cannot impact as easily as we would want. So in recording the metadata, according to that, we would define or select local climate zones into 10 building type series or 7 land cover series. We also recognize seasonality of land cover properties, which also can give you more finer aspect to it. So based on data, 2010 data back in 2012, this was the area, or this is what a local climate zone map of Colombo looked at. But here, even though we present it on a 2-dimensional scale, we know that this is a 3-dimensional morphological map of Colombo, where each of these zones will give you morphology, that is physical properties, height, width, spacing between buildings, etc. It also shows critical areas that we can take on. Looking at all these maps that have climatic as well as physical properties. So we know that certain areas can be more impacted. Here in 2000, according to 2010 data, most of Colombo was LCZ3, that is low compact low-rise areas, and then the compact high-rise areas that have increased since then are very few and far between. So this gave us a situation where we can still see that Colombo is not that bad, and then in identifying these areas, we can approach it. This map also shows you very definite areas of the city. The yellow zones, more compact, low-rise, more fluent areas. And then we see the compact mid-rise, especially on the Marine Drive, where we see more residential and influx of commercial coming in. North of Colombo is quite different, and so forth. Knowing that an area is not uniform, the local climate zone classification system also allows you to sub-classify, where influx of another or input of another pattern within the greater pattern is allowed. Here, the main pattern, or what is more predominant, is given priority, while we still say what is joined with it, because these can have climatic impacts and warming impacts on the local level. Imagine Colombo nowadays, where the compact low-rise, compact mid-rise areas along Marine Drive, again I would take that example, where we have high-rise buildings just coming up in between these low-rise context. We would imagine a higher anthropogenic heat flux, higher AC use, more vehicles into that block, etc., pushing UHI. See, we went about subcategorize or sub-classifying local climate zones for Colombo. When we looked at this, we saw that there were almost 42 patterns. But when we presented this to Stuart and Oak in that forum, they were, what can I say, they were worried that this local climate zone definition was not really meant to be a fine detailed one, but to move to generalize areas better, where we can understand and simplify enough to compare zones. So we look, taking those comments into consideration, we look to a more coarse subclassification or a coarse categorization of this, where local climate zones infused with building series, we put into one category, and then local climate zone subclassified with surface cover series, we would bring together. So that gave us a better idea of a much better picture that corresponds to what is on ground. Now we were talking about UHI. So this mapping exercise was tested in this sense. This mapping exercise, we looked at the impact on urban heat island or local heat island effects or local warming effects. To do this, we used a numerical simulation called surface heat island model or SHIM, where we used the cooling of urban canyons, the rate of which urban canyons cool during nighttime. We know that urban heat island is a nighttime phenomenon. So we see how, and it is the difference in the cooling rates between these patterns is what is defined by urban heat island. Here we use this surface heat island model to see what is the urban heat island intensity and what is the difference between a control site and a particular local climate zone. So this table shows us that. It shows that the more compact, dense areas that are heavy with population and vehicle use are more warmer, almost 4.4 degrees warmer than a control site. While the more open areas, more less dense areas, which common sense tells us are cooler or cool faster. There are also interesting factors here where we see areas that are defined as large low-rise or areas that are LGZ7 lightweight low-rise. So lightweight low-rise would mean areas that are of lighter materials as opposed to heavy built materials. Examples may be shanty areas where very lightweight materials are used, and then we would imagine them to be warmer. But here we can see that it cools fast. So we can imagine that the incoming solar radiation comes in fast, warms the space, but because the materials are lightweight, it would also escape faster into the atmosphere. So that is why you see a better situation there. That doesn't mean that it is better for living, but in terms of UHI intensity, we can see these areas as a difference between the other areas. So having learned this or mapped this, so the local climate zone map for Colombo was the first time that we looked at a map of Colombo in terms of morphology, physical properties, and also in terms of climate. So how can we use this climate-based approach for application, especially for urban planning? We saw this is a simplification of the context. So that means we can deploy this rapidly or at faster rates than we would go about of collecting data or intense data, detailed data of an area. And this system doesn't need that as well. This area is to simplify and understand what an area of certain morphology will have on urban heat island. That is the main advantage of this. And as I mentioned earlier, we looked at urban blocks. So urban blocks can be easily put into effect for changes when development is planned, etc. What happens when one area turns from one LCZ to another, and what is the climatic impact on that? What is the change in morphology? How it impacts the people on the street? And we also, in mapping and defining these areas, we know that we have several design parameters. Out of this question arises when we go into a planning regime or an area that we can apply these things or changes. What are the parameters or what are the primary parameters that we have to touch upon? We know that we cannot look at everything. So what are the most important parameters? Because we are talking about design and morphology, so we concentrate on the geometric and the surface cover parameters and leave the metabolic factors aside for now. So to do that, we also looked at what happens. Do we look at the current or the present, or how these parameters can change or inform future decisions? When we make plans for the future of the city. Right? So we say Colombo's planning approaches, we will say 2030, and so forth. So we are looking ahead. So here in our studies, we looked at what is the impact now, and what is the impact, say 2100 or 2100, where studies say the whole island, whole world will warm. Whole world will, the temperatures of the whole world will increase by 2 degrees or whatever it is. So we pitched our studies from the now as well as the future. We also looked at Colombo, as I mentioned. So to do that, we approached a simulation-based approach where we studied or we pinpointed certain areas of a typical urban area in Colombo and looked at the morphology changes or changing morphology on these particular parameters. So we used a simulated matrix of almost 96 models where known urban design approaches were applied. Say, we know that shading is a major part of our urban heat island mitigation approaches. So therefore, how do we shade the streets? Which streets do we shade and which streets do we leave be? So all those morphological aspects we applied into these models. So we have models that are of same height or buildings with same height, taller buildings on the street edge, or taller buildings on the center of the block, etc. Common sense tells us the shading, according to our context, will drive the cooling aspects of it in different ways. And each of these, we would record these parameters. And the idea was in going into statistical approaches to see which parameters have better intensity or better applicability to mitigation was the way we went. So ultimately, we saw that when we compare mean radiant temperature as the main aspect of it, thermal comfort or thermal impacts on the street level, and we looked at that and the impact of geometric and surface cover variables, how it impacts mean radiant temperature. So we can see stronger relationships in the globally warmed scenario. So we can see that it shows us that looking at geometric elements can have a better impact in the future when it is more warm. We can see that the influence of variables was also significant in the night time. Now, urban heat island is a nighttime phenomenon, so that gives us some food for thought. Where when we are trying to mitigate, even at a time where solar radiation is not there, right? So we're not there, so we have to impact it in the daytime where it warms, but look at the nighttime where we need to impact. So we can here see both the existing and the warm climate were conducive, or these parameters can be applicable. Our results also showed that the sky view factor has the strongest relationship to MART. So controlling the amount of sky that we don't see during the day and the amount of sky we see during the night has a great impact on it. So sky view factor is the primary element for urban heat island mitigation. We also saw that the geometric variables took precedence over the surface cover elements. So it is the form of the buildings, the morphology that is more important rather than the surface cover around buildings. It's not that it doesn't have an impact, but in terms of intensity or the applicability, the geometric variables take precedence. It also allows us to look at future development, where we would define more about morphology or the form of the city rather than the surface cover. Other elements we saw that was ground cover or vegetation had little or no effect. And this was also goes with known knowledge as well. So within that, also when we look at local climate zones, orientation and morphology was also evident. The impact of various orientation and morphology was evident. So with this in hand, we went on to the next step of looking at a local climate zone based approach to urban planning in Colombo. How can we apply this? How does it apply to Colombo? What can we look forward to in that sense? So as mentioned, urban morphology, both geometric and surface cover, properties can be applied into a mapping protocol. So this mapping protocol then has and will bring back opportunities for climate sensitive as well as context specific urban plan. So zoning plans for the city right now use more activity based zoning rather than, so more physical rather than climatic. Here with the local climate zone, we will bring all those parameters into the system. And so whatever it is, cities are to be habited by people, habited by people. So therefore, it is not only the form of the city or way it looks or way it is used or developed, but also how people will use or be comfortable on the street level. So therefore, the climate aspects goes without saying, the importance of climate aspects. So as the map of Colombo showed, a local climate zone mapped area shows easy identification of critically stressed areas. With we know that certain aspects will generate high intensity, so we can see these. We also can see areas that we can preserve. We can see areas that we can identify to develop and not develop, or the intensity of development. Can we change in morphology? How can we minimize the impact on the greater area? We saw value ranges in our definition or the data sheets that we show. Right? So there is a value range. So we can use those ranges to our advantage. Say, for example, height of roughness features go from a certain height to another. So it's a simplification of the area. It's not specific. Also, the idea of sub-classification. So that allows also areas. So a highly dense area that is interspersed with open areas to allow mitigation. A good example of it is the shadow umbrella approach, developed by Rohinton Emmanuel, where the city itself or the block itself shades its own buildings, shading others for the greater good of the urban block rather than plot by plot as we look at now. So what are the implications for planning? So simplification of the context allow generality and applicability across similar contexts and climates. Then by knowing the sensitivity of morphology variables like SVF as the primary element, we can look to control now and in the future as well. Our UDA city development plans take it on in terms of these areas. The larger context, zoning plans or planning regulations, density regulations in a next scale, building regulations in terms of individual plots, and also they have these development guide plans where they look at a certain area and apply specifically. So we can use this structure as well. Where zoning plans, we identify parts of the city that we need to control morphology. And then in this scenario, we can have the sky view factor as a primary variable. Now we use a term called zone factor, and with a zone factor, a flow area ratio, where it is all based on density and how we build on a particular site. But here we take it to another level. We look at it in precincts or in local climate zones, how a local climate zone shape itself, and also interact with the next climate zone next to it. So these are, it is advantages. See, in Colombo, we have areas that we can easily exploit. So the patterns that were developed from these looked at these. Density regulations. So we know that a local climate zone is a simplification of this. So in knowing the local climate zone, immediately we have a situation where density is defined. Height of roughness features, packing of roughness features that talks about spacing between blocks for not only for vegetation, etc., but also for wind flow. And so in looking at that, we can look at a larger picture, and we know we can define a maximum development that will not affect or impact the future. For example, Hong Kong has something called air ventilation assessment, where the ventilation of the total city is the focus rather than single blocks. So when we build on our own blocks, they know how it impacts the greater context. But here we can come back the other way around. We can define the property of the larger block and then look at how people are allowed to develop. This has other problems. It raises questions how urban planners will incorporate this, and then how do they handle social and economic needs and factors. So as mentioned before, the building regulations will take a more zone-wise aspect, and we can use SPF as the primary parameter rather than block or plot-wise. So we know Form C of gold. Form C has changed into different things in our urban UDA planning regulations. So we would see not Form C for a certain plot, but Form C for a urban block or a LCZ precinct. So it gives greater flexibility. People who want to build more, so you can take on different aspects of it. Difficult, yes, but then different contexts. Precincts, say C-Fund precinct will be very different to a more inland one. And then development guide plans, as we see, will have very definite areas. So this goes well with the current structure that the UDA uses. So this study or the local climate zone, mapping local climate zones and to understanding and driving urban heat island mitigation, we saw advantages and ways forward to apply these things. Especially in a data scarce context, where we can look at context and then apply rapidly, where a developing country like us needs quick decisions, but these quick decisions cannot be arbitrary. It has to be very much based on informed decisions. This allows us to inform our decisions in a rapid manner without waiting for years to collect data and look for answers. However, some caveats are in order. We can see problems with this system as well, where simplification of a climate context can have aspects where we oversimplify, and therefore some things can be missed. You can also see limitations of a future zone-specific planning approach. Local climate zones were not meant to be planning zones, but a way to understand the context. Therefore, we cannot use them directly. But in doing so, having this system in place, we immediately have a situation where we set our base in terms of geometric surface cover, thermal, radiative, and metabolic value ranges. Therefore, we can work within that. We can work not only with the morphology, but also in terms of amount of people in a space, what are the materials that we use, what are the colors of the context, etc. Interpretation into value ranges in a LCZ base is also problematic, where it is not meant to do so. So we can imagine, so it has to go beyond a simple, the classification cannot be a plan. It is a step to inform plan. Subclassification also has problems, where our data sheets and parameter ranges are for the main local climate zones. These are not defined for sub-classification. So that's a problem as well. So in conclusion, the need for context-specific knowledge from several tropical cities in this data scarce yet rapidly developing region is emphasized. This knowledge will only enrich both process and classification and sub-classification, thus enhancing its usefulness. In the second part of my presentation, I will take on the building scale, which is also very important in my studies, in our studies that we have been taking on, and the area that I do teach on or have taught for a long time. Building scale looks at passive design strategies. Right, as we looked at climate sensitive passive design strategies for an urban context, here we know that the building scale will impact the city scale or the urban scale, and vice versa. It is recognized that cities drive UHI or is a major driver of urban heat tide. So the little part we do here will also impact the greater or the larger context, and vice versa. So in this aspect, I was also fortunate to be a part of the energy efficient building code for Sri Lanka, which we have been developing for a long time. And it looks to be mandatory in the near future, where we look at energy efficient buildings that have to go through a certain regime to comply. So here, in all of these, the critical factor is the building envelope, or the building that will hold habitable spaces where people occupy. These are some diagrams that I developed for a guideline for sustainable energy residences. It was a small, it was not a research work as such, but an application agenda that somebody holding this can inform themselves. So these certain patterns are where we focused on. Where we start at the neighborhood or context level, where we saw in the urban scale, we must have a microclimate that is conducive for natural light and ventilation. Otherwise, it is useless. If a microclimate or the area, the outside is bad, you bring in natural light and ventilation in, it is as bad inside. Right? So the outside should be conducive to allow the inside to be better. So we start at neighborhood level. And the second strategy talks about shading. We know that in our context close to the equator, sun is high in the sky. So most of the time we have sunlight coming on us, but the advantage of the sun being high in the sky is we can shade and we can cut off. Unlike in the southern and the northern hemisphere, where the sun is low in the sky. So shading devices really don't work. So this shows several patterns, starting from the site itself, certain strategies that we would use to cool the building envelope and the interiors. We can shade using external features. We can shade using building features. How we shape the envelope, how we create shading devices inside and outside, etc. So most of the radiation impacting the building envelope is cut off. Similarly, important is ventilation. How do we shape our building to catch maximum breeze? How do we use our fenestration, inlets, outlets, sizing, spacing, so that we can create cross ventilation and stack ventilation that takes out the radiation that has come into the space? How do we use ventilation together with evaporative cooling? We are planting on the building skin planted surfaces outside will bring cooler air into the interiors. And lastly, how do we choose materials wisely? What are the materials that we would use to reflect, delay, and keep out radiation totally? How do we use colors, insulation, etc. and materials that not only in terms of energy use at this level, but also at the source where we can talk about embodied energy, etc. Quickly explain these factors, I will show some of my own work. First example is from a house, term solus otus, where Latin term, where the came from the clients itself or the owners or the homeowners themselves, where they want to gift their children. It says solus otus means gift of the sun. But here, in this sense, the natural elements or the rhythms of the day will impact the living spaces, etc. The question was, how can we do this in this urban context? How can we open for vistas, bringing the outside in, shade, filter, layer this. So this is the context. Palavatta, you see Surupai on the right, and almost a landlocked site, but still has greenery around. In impacting, we looked at this as a space that looks inside. So here we have several layers or zones that allow or filter the internal spaces. You will see each habitable space is open to two open areas that we can bring in. And it is not borrowing from the street or etc. It is within the site itself. The zoning within the site creates at different times of the day warmer areas and cooler areas. Because of that, we can easily encourage natural ventilation through the system. We also can see several envelopes where spaces are insulated from the outside, not only in terms of accessibility, but also in terms of natural areas, shaded areas, etc. So the left-hand side is the lower level, and the right-hand side is the upper level, where the north-south facing habitable spaces also take that same aspect of it. What does it do for the architecture of the space? In terms of section, we can see these things, see these spaces, where each of these sections shows where each space opens up. On the right-hand side, we can see a screened area where, although the rooms are devoid of windows, we have several layers that insulate and allow evaporative cooling, allow shading, allow plants on the building skin. And then the living space is a roof garden, where it is the earth itself and the plants itself insulates. Both these examples I show you today are net zero buildings. So we generate our own energy as well. The first layer, here is the street edge. We can see to the person outside, it's a solid element. So it becomes a filter for not only the people on the street, but also the elements coming through this screen. Though it is solid to the solid on the outside, when you are inside, it is translucent, transparent corridor. So this is the entry courtyard, where the outside is visible. You can see outside, they cannot see. But you can see this series of pockets of natural elements that we can, creating its own microclimate that can bring in natural light and ventilation. Another view of the courtyard coming in from the door. So we can see these fenestration also. So these are grills that have bamboo tacks. So the bamboo tacks can go up, still have the grill as protection. The whole grill can open up so that the whole space is open. We also can see the shading elements, the plants on the building scale, and the roof garden. The larger space. So these two open spaces work in tandem. When one warms, other is cool. The other is cool, and vice versa. Also, we can see the layering of these shading devices and openings. You can see how it protects. Transition space that connects. So this is a situation where when it's totally open, it is just one with the outside. So in terms of having a space that is cooled down or knowingly created microclimate, the internal space also can be the same. Here this is an area of more shade, so it will be cooler than this just a space outside. But this allows space to expand and the wind to pass through. Another view connects these gardens, and we can see the material palette also that we have used. So low embodied energy, again, we have used cavity walls, and then situation where the finishes are such that we don't have to use, or for maintenance, we don't have to paint it every Christmas or whatever. So we can have a situation once done, it's done. So not a recurrent cost factor as well. The upper level that easily allows access to it using native vegetation, fruit trees, they're bringing birds, butterflies, but the children themselves can pick fruit off the branches and eat. A space that is protected but given privacy, shaded, and layers of access. Maybe as views of the skies, birds flying by, but still space that is shaded, space that is conducive for habitation. In the second example, I take a rural situation where we were fortunate to have a free hand to apply certain factors to the maximum. This is an estate bungalow in Hangama, an estate, cinnamon estate, around 12 acres. So it was an existing plantation, and we had this plateau at the top that didn't have cinnamon. So that's where we looked to build. So the idea was to create a forest clearing. So the whole site is planted, where this plateau becomes just a clearing in terms of space. So you come through series of narrow paths in between the cinnamon, and then you just open up with the sky to the as your palette or your canvas. Also, we looked at, because this is a rural site and the way we build in these sites is also important. We looked at a very low embodied energy material palette. So a very low embodied energy material building that sits on the earth very light. So the idea was, as you see on the right, a building that is almost skeletal, and at the end, hopefully the plants will take over. Also in terms of form making, though we had a radial form, we used these, we wanted to break this, where the context itself drives where people look towards. The context itself looks to where we place certain elements. And then also because of the sun's movement and the wind patterns also govern this. We give priority to the main areas with this. The idea of this radial structure, we break it or we juxtapose these living spaces so they it's not symmetric, so it becomes part of the forest itself. Remember, I said it's a part of the forest clearing, so the living areas are part of this forest or vegetated area. So the layering of this building or placing of the building of the hillock also allowed us to tuck in certain places underneath, move into the forest itself. We are here, the top plateau is above the plateau or above the tree lines. These will go into the tree lines and then allow them also to different microclimate to take its advantage. So this is an image of that, where we have going off the plateau level or the bridge level is one level, and then you would imagine all of this part to be a part of the landscape itself, so that we can look out onto the vistas. So it looks like this in terms of placement. So you can see the plateau level or the bridge level and the other spaces cascading down the hill together with the plantation. Another view of that. On the plateau level, it's a simple single line. So it's not a large scale building, or not meant to look like a large scale building. And it is, we handle the solids and the voids very carefully. So we can open, close. So the facades also change with the opening and closing of the fenestration. To the bridge is the connection. Everything else, once you enter the spaces within of this bridge, you are free to experience the natural elements, natural landscape. So here we can see the material palette itself. All the structures are timber, and then a very lightweight structure that doesn't touch the ground, only these verticals, tree-like verticals, or tree trunk-like verticals, or they are tree trunks, so that they are ones that will carry these very arbitrary, broken spaces. Emphasis on the structure. So we some we build or we fill, some we let be, so that it can create its own space. We see how these spaces have grown or evolved later. Infinity pool that everybody requests for, and as I mentioned at other forums, this is the only area that the embodied energy factor was questioned. The concrete use could have had other alternatives, but the price of other alternatives are questioned. So we kept with the concrete. Spaces are meant to be looked out into, and then allow the landscape in with the not only the landscape but light also. Here we see the single-story spaces punched by skylights or shaded skylights that allow light into the interiors, then also mimic the light penetrating a forest canopy that we would imagine. Materials, interior, both outside and inside, encourage or conducive for the touch, so that it can be experienced. People can be a part of the structure itself. The different times of the day paint the spaces in different colors, and it morphs, changes the volume, changes where we would look out. Materials used true to its own texture, color, form, so that it will allow plants to take over later on the structure, fauna, and the flora taking over the building. As you mentioned, this structure is meant, or these spaces are meant to evolve with the changing vegetation, light, etc. These last few images show how it has changed in this very short span of a couple of years. So slowly but surely, the landscape will take over the space. So climate sensitively, we have several layers, shading, and allowing easy access for ventilation right through. Keeping the material palette simple and low embodied energy. With this, I thank everybody present here and who have listened to me today. Some of you would have seen my work before many times over, but I also thank the university and the Faculty of Graduate Studies for giving this opportunity, and also the opportunity to profess what I have learned and want to share with everybody. Thank you. And may God bless you.
We sincerely thank Professor Narein Perera for his insightful session. Your expertise has truly enriched our gathering. It is now my privilege to invite Professor Yasangika to present the lecture memento to our esteemed Professor of the Day, Professor Narein Perera. Thank you. Before concluding, I wish to acknowledge the generous sponsor of today's lecture, Carlos Private Limited, the event sponsor, Daily FD, the print media sponsor, the Sri Lankan Scientist, the social media sponsor. With this, we officially bring the 33rd inaugural lecture to a close. Please mark your calendars for the 34th installment where another captivating topic awaits. Thank you for your time and participation today. Until we meet again, take care and have a wonderful day ahead.